Hi, I'm Tom English, and today's lesson in geometry is on the circle. And there's many parts of the circle. If we just start with the center of the circle, the point P in this case, and we tend to label a circle as, this would be circle P. The distance from that point to the outer edge of the circle is called the radius, and the distance all the way across, in this case the E to F, is called the diameter. And of course from that you can hopefully tell that the diameter is obviously twice as long as the radius. And we use the radius in order to find the area of a circle. The area of a circle is equal to pi r squared. Pi is the letter in the Greek alphabet, and it's used to distinguish for circles. Pi represents the ratio of the circumference divided by the diameter. And that's an irrational number that as a decimal goes on forever. In fact, I've seen some classrooms with 3.14 all the way around all four walls of the room. So if you want to take it that far, but I think most people will be satisfied just to use the decimal 3.14. If you're dealing with problems that happen to have fractions, you might find 22/7 to be more convenient. And either one of those is acceptable, but by far, especially in the days of calculators, 3.14 is the meaning there. So we have the area is equal to pi times the radius squared, and the other formula that we'll want to lock in is the circumference. And the circumference is actually pi times the diameter, which is how they calculate pi. But also, since the diameter is 2 radii, you could also say the circumference is 2 pi r. Okay, those are about the only real calculations we're going to do here initially. But it's important to know the other parts of the circle other than just the radius and the diameter. Up here at the top, AB, that's considered a chord. And a chord in a circle is a line segment that ends on the circle itself. So A is on the circle and B is on the circle. And that's called a chord, which is different from a segment in that the segment passes through the circle like C and D, but its endpoints are outside the circle. Okay? And a very special segment is called a tangent. And a tangent is a segment that touches the circle in only one point. And another factor to lock in on is wherever that tangent is, it would be perpendicular to the radius that's drawn to that same point. And you'll end up, and we just finished with trig, you'll end up with some right triangles here to calculate some angles and distances and so forth. So remember, the tangent is a segment that touches the circle in only one point, and it would be perpendicular to the radius at that point. Another important part of the circle is what we call a central angle and an inscribed angle. And unfortunately, kids seem to get those mixed up. The central angle has its vertex at the center of the circle. In this case, angle ACB would be a central angle, and again, we tell that by the vertex at the center. If the vertex of an inscribed angle is on the circle itself, and again, it's inscribed, this angle is inscribed by the circle, and the big difference here is that this angle that is inscribed, you'll notice they both intersect the circle at A and B. The central angle is you measure that angle, and that, first of all, I neglected to mention the total circle is 360 degrees. And if you put your protractor and measured angle C here, that in this case is 140 degrees. And so the central angle is its full measurement. The arc then, in this case AB, is defined by the same degrees that are in the central angle that defines the arc. And the difference between central and inscribed, an inscribed angle with those same endpoints, you'll notice is 1/2 of the central angle. So just a little fact to stick in the back of your mind, that inscribed angle, if the vertex is on the circle itself, on the circumference of the circle, then its measure is 1/2 of the central angle using that same endpoints or the arc. So it could be 1/2 of the arc. Okay? We also, when we're talking about arcs, arcs is the circumference, or the part of the circumference that's being defined by an angle. And in this case we have arc AB, 140 degrees, and that's considered the minor arc. It's the smaller of the two, because if we were referring to the arc back here, the bigger arc or major arc, you usually have to stick another point in there to be able to define the difference. Arc AB in this case would be the top portion of this, defined by central angle C, and it is 140 degrees. If we're talking about the larger or major arc down here, we couldn't say arc AB again, or you wouldn't know the difference between those. So fortunately we have a third point here, or you would put in a third point, and this would become major arc AVB. And again, if the total of the two have to be the 360 of a full circle, if the minor arc is 140, then the larger arc would be 360 minus that, or 220. And finally, I wanted to show on this one, here's a case where we've drawn a diameter AE, and so hopefully from that you could see that, well, we've got an arc of 180 degrees, and also an arc on the lower half of the circle. But you could see that any inscribed angle that uses that arc, it would be 1/2 of the arc of 180 degrees, or it's going to be a 90-degree angle. So one little point to remember is that if you have an inscribed angle that is inscribed by a diameter, or the 1/2 of a circle, obviously all those are going to be 1/2 of 180 or 90-degree triangles. So in this case, ABE is a right triangle, and triangle ACE is a right triangle, angle ADE. Any place I put that third point on that arc is going to end up being the vertex of a right angle. Okay, we're going to take some additional ones in the next video, and hopefully there'll be enough meat here to enjoy for your circles. Thank you.